I should probably stop being distracted by the fact that I was reading the Rust documentation and realise it was 9 o'clock already. Oh, good morning, everybody. This is kind of how today is going to go, I think. So I have... I think I'm probably got more to learn than you do on this at the moment, Seth, so we'll see. Oh, Twitch, you said that and my first thought was to check all of my settings and see if I was muted. I'm not doing well today. We will see. Because I know a thing that I want to start working on that I can kind of build up fairly gradually. Because ultimately what I want to try and do is a priority-based work-stealing task scheduler. There's a bunch of stuff I'm going to have to learn, so I'm going to start on the easier things. In fact, I can probably make some notes in here quickly. So, ultimately, what I want is a bunch of priority buckets of work. They need to have threads. I can probably also make my text a little bit bigger on here because I forget sometimes that I have fucking tiny text. Oh no, it's right here. I can probably go a little bit bigger than that. I have a big enough screen. It's going to be very strange for me, but, you know, that's probably slightly more readable for everyone else. I'm honestly kind of surprised that I had it set as high as 14. That's a bit large for me normally. Yeah, that's fair. I don't know how big these are. I think these are 27-inch, but 4K. It's a problem I used to have at work all the time. So I had to use VirtualBox, basically, or any other VM system, but I used VBox. Because we had Windows PCs and I was doing Linux development. But then I had my console setup set to be like 10-point terminus. And any time I was sharing through Teams, nobody could read what my text was. Because I was doing everything in Vim in the terminal. Green on black. I ended up having a second xdefaults file that's like, oh, I need to share my screen. Let me load my other xdefaults and then share. So, yeah, one of the points I have here is... So the way typically a work-stealing task schedule will work is you put work in the big work pool, a thread will come and take work. If that task generates more work, it's added to that thread. So a thread that's already busy with something will work on stuff that's local. Other threads that aren't busy can take things off the back of that queue to work on, so that you try and maximize throughput. I want to be able to selectively block that for some types of work. I also want there to be a system where some work is just more important. So you end up with a sort of series of things like this. So say these are 3 queues of work. So you have like a high, medium, low priority. So you can start filling in work in these. And you should do the high priority stuff first. So you take the front one off, and then this will move down to be here. But if, oh, that was not the right button. But say this finishes, this one is still running. Your medium one could steal this piece of work and say, hey, I'll just do that for you, as long as it's stealable. So what this means is when you add work to the central pool, so you have your big bucket of work up here somewhere. And this has your various bits of random work. This then needs to be able to distribute these down into whichever bucket. So these need to have priority on them. This whole thing needs to understand which queue is for which priority. So, and I need to be able to jump stealable work. But I don't really want to change the order, so I need to be able to iterate over it. So I'll probably store an extra iterator. So per queue, you have work items. You have a last or first stealable, actually. Per set of queues, and then you need a thread pool, you need a priority lookup and dispatch. A worker, you need a run, you need a steal. So one of the things I've been looking at, trying to start at the lowest level thing. I now have a new thing that lets me just see all of the chats at once. Just in case anybody is chatting from YouTube as well. So one of the things I've been starting to look up is basically how things can degrade to function pointers. Because we want... And it depends. Depends how restrictive I want it to be, if I want it to be completely free or not. So I guess, first things first, let's start with a version that just does work that basically matches add. So we should be able to do something like this, right? In fact, almost exactly this. Except I don't actually want it to be I-32s, I want it to operate on U-32s, because... Also, if I'm going to use this, let's make it do U-64s. So then, in theory, what I should be able to do right is... So I should be able to, I think, make a struct... Where's the thing on making structs? Just... A lot of this is learning Rust-specific syntax and restrictions, right? Okay. Yes, okay. Is braces, that's what I expected it to be. And then, so you don't have to use a let. So it's just... Oops, that probably needs... I better know what this is. Yes. One thing I'm going to do while I'm learning, because I do not need this right now. The thing I use to keep me on my toes is syntax gaslighting. Oh, the charm. I seem to recall there was like a shaman or something. Is that what it's for? Like a shaman or a witch or something of that nature? No. Hooray! So what am I not allowed to do? Expected function, tuple struct, or tuple variant. Okay, so how do they use in here? How do they function pointers? So they just do... I'm trying to kind of conflate a couple of different things here. Can you not... Oh, no, wait, I think I know what I did, actually. Whoops. that should be that, for one thing. Expected function, tuple struct, or tuple variant. Did I use the wrong syntax for making a struct? That's probably what happened, right? Oh, yeah, okay, you have to be much more explicit in Rust. That's the... So hang on. Right, yeah, okay. Oh, also, yes, fine. I'm clearly coming from a different language here. Oh, okay. That's odd syntax to me, but sure, if that's what it says. Okay. We're working it out. And then... In fact, then, what I want is to do... so, methods. Okay, so you do still specify self. So that should work? No. Why does it not? Such error, much wow. And methods with a Oh, right, because you... Oh, it's very Pythonic in that sense. Okay. Wait. Oh, because this is now a method on the struct, not a function. Okay, fine. Yeah, that's the difference. We're learning. Yes, so... Oh, sorry, up here. Yes, I think we do, Seth. You're right, probably. Because that's calling a function pointer. Mismatch types. Why is that a mismatched type? That's an interesting question. What? The self.op is a U64. This is saying it's a U64. The semicolon? Am I missing a semicolon? Oh. Oh. Thank you. Yeah. There's a lot of, like, there we go. So this should then fail. Hooray! It fails now. And then that should pass again. Okay. Yeah. I think this feels like quite a lot of progress very quickly. Yes. Yeah, looking through the book, I haven't seen them ever use return. So I think I just kind of missed the fact that their standalone expressions then don't have the semicolons. But actually, let's not do that, because I'm going to run into weird type issues if I do that. I'm now curious if it lets you do this. Oh, it does? Okay. So you can replace variables like that. Yeah, absolutely, Seth, yes. But okay. We have at least a basic type of work item. It doesn't do very much right now, but it will run different operations depending on which one you tell it to run. So I guess a real test now is going to be I should just be able to do the thing. Why am I even doing that? I don't need to do that. Can you have nested functions? One way to find out, I suppose. Oh, in fact, actually, here's a real test. Here's a test and a half. Closures. Are closures what I actually want? Probably not. At least not right now. I can get to those later, I suppose. Okay, you don't... If 1 equals 2, whoops, mathematics broke. But do you actually have to do it that way? That seems unlikely. Hey, Araim! Oops, yep. That will happen sometimes. But thankfully there's an infinite number of people to come back. Well, enjoy the outside as well, Rain. I've heard the outside is scary. Where did you expect a semicolon? Oh. No, that's why. I forgot that it's implicitly putting in that bit for me. Are deadly space lasers from the sun. Okay. That seems like quite a good start to me, because we also now proved that it works with public methods we've defined that meet this, and also that we can define our own one and use it, and it still works. So, yeah, I'm quite happy with that. I mean, the work item definitely needs to be better, but to start with, that'll do. Like, I've never used Rust before, so... As is very obvious to anyone who's been watching this far. The next question, can I not enough is the answer. But I think enough that ownership is the thing I think is going to be the thing that kills me here if I'm not careful. And hey, you can add to strings. Okay. Yeah, so this is using boxes, presumably, under the hood, or something equivalent to boxes. So we... Okay, so yeah, S2 steals S1. Move occurs because of string, which does not implement the copy trait. Consider cloning the value of the performance. Yeah, okay, that makes sense. I'm going to have to start looking at traits at some point as well. Okay. Yeah, okay, so that actually takes ownership, so when it goes out of scope here, it gets freed. Which is neat. Move its return value into the function that calls it. Okay. Takes and gives back. Literally just takes and gives back the parameter. Does nothing with it. variable that includes data on the heap goes out of scope. The value will be cleaned up by drop unless ownership has been moved. References and borrowing. So, yeah, so you use the reference thing, which makes sense. So calculate length here doesn't... Yeah. Because that's why here you have to do ampersand self, right? Because otherwise you move yourself into your own method, and it... Let's not get into questions about that. At least my understanding with the function pointers is it does a bunch of like implicit reference handling stuff for you. Wait. Hang on, what's going on here? Mutable references. Okay. Value is this. Yeah, okay. You make a string, you calculate length. Okay. I mean, with our work items, we probably don't want to be doing this. We want the work item to own its own data in any case. Which is not happening at the moment because integers, but, you know. Yeah, so you can't borrow it as mutable. So yeah, it wants you to make a mutable reference. Which, yes, okay, you can do. You can say here is a mutable reference. And you pass in a mutable reference. Oh, and S itself has to be mutable. This doesn't compile. Mutable borrow, second mutable borrow. First borrow, later used here. How borrow? Oh, okay, so you can only have one mutable reference at a time. Yeah, so it stops data races, essentially. Oh. So you have an immutable borrow, and then a mutable borrow. Okay. The priority is on protecting the reads, really. Because I just read this as I want a borrow that doesn't change the value, but I'd want to see changes to the value. So that actually kind of surprises me. Okay, so yeah, because they've used it there, the compiler then works out that it's not being used. Borrow Checker does some clever shit. Dangle, dangle. This function's return type contains a borrowed value, but there is no value for it to be borrowed from. Yeah, so you can have one mutable or any number of immutable references. That's probably going to be important. Also, I got distracted. I was looking at vectors. I'm now just curious if you can do this. Okay. Would help if I remembered the parens. Why is there an error here? Because I don't know how to define a fucking function. Um, 5 is probably enough, right? Does this still work if I just put it in the test code? To save having to redefine it everywhere. Although it's still nice to know you can make nested functions. I don't know if I ever want to. And then that panic. Also, side note, not relevant to learning the language, I adore that they've called their mascot Ferris. Okay, so you can just for I in V. Okay, that'll do. Actually, I need to double iterate, don't I? We want a vec of U64. There's a couple of ways I could technically do this, but this is the way I've chosen to do it for whatever reason. This is going to be this. This is going to be 0 because of how I wrote sub. Yes, I'm aware it would otherwise be -2, but... there is a thing somewhere... about iterators. Where did I see iterators? I thought there was an actual iterator type. Oh, there we go. Iterators and closures. Processing a series of items with iterators. Okay, so you can just call .next. It's good. Does that need to be mute? Is the question. If I'm calling next, yes, that is what I expected. Set eq I dot. Do I have to deref that though? Yes. And we're asserting that equals that. Why can the iterator to a vector not be dereferenced? That is a question I have. Is there something obvious I am missing about this? Will the next method change its internal state? Yes, that's why you'd have to make it mutable. Oh, I see. Okay, interesting. Wait, hang on. Did I do something? Oh, no, because that isn't an iterator, so I don't need to do that, do I? I don't think. The next method. Oh, sorry, I was lost in documentation. The next method. Oh, okay, fine. Wait, so does iter not... Oh, the default iter doesn't have the, right. Yeah. What does unwrap do? Oh, okay, unwraps the sum value. Okay. That is because it's not called V. Yeah. But this should be... Slice iter cannot be... Let's not unwrap. Yes. But I mean, hopefully, if I've written the test correctly, it should be the same length for both of them, so I shouldn't need to do any specific extra checking. This might just be IntelliSensus not quite catching up. No? Okay. Oh, sorry, do I still need the star there? Hang on. Oh, expected U64 found and U64. Sure. Okay. Yeah. It makes sense that they do return a reference. It's just not what I expected after all the documentation saying that it'll copy integers and not. But it has to be written to handle returning things that aren't integers. So. Yeah, it makes sense. So yeah, I think part of the problem I had, as you rightly pointed out, Seth, is I had expected this to already be pointing to the first element. There's probably a much neater way to like zip two things together and. Yeah, it's been a long time since I've done Java as well, so. I last wrote Java code in 2014. Yeah. Yeah, generator iterators are quite nice. I don't hate it. Yeah, there's a lot that's a pain in C++. I'm not out here trying to say C++ is in any way perfect or a single language. C++ for me is a little bit like I just got an invitation to play a new programming game. That might be a thing we do at some point soon. Yeah, but what I say is C++ to me is a bit like the English of programming languages. It's taken shit from everywhere, and it's not really very coherent or cohesive. Is it going to murder me if I try and do this, is my next question. Oh, yeah, I don't need the semicolon. Yeah, I was going to say, I'm much more familiar with that iterator model from Python. And I very explicitly want this to take ownership. I'm totally on board with this. I've been so brainwashed by industry making me write everything in fucking camel case. And yeah, no, completely agree with that assessment, Seth. It is... Iterators in C++ are really clumsy. I've spent the last 10 years working with them daily. Much like the fact that I've been forced to write everything in camel case for so long, despite the fact that my preference is actually snake case. It's... You get to a point where the habit takes over more than anything. And it goes to show you how easily your own mental model can be warped by some of this. But this is why we're learning, right? Taking the time to actually, yeah, I'm gonna fuck up and I'm gonna look like an idiot sometimes, but that's what I signed up for. Like I say, it's a language I've never used. I want to learn it because I think it's an important one to learn. And it's also important to learn where it differs from the things that I've just kind of got used to and come to accept. But, like I say, one thing, yes, okay, I'm a lot older now than when I first started trying to do any of this in C++. I've got a lot more experience. I would not have dared try to write something like this from nothing in a language I didn't know. And yeah, no, if that's your default mental model, then it's definitely going to help you. Yeah, I'll be honest, my brain stopped on iterators, like, oh, the syntax looks vaguely what I'd expect, and just defaulted to what I'm used to reading or writing. Yeah, I completely missed the fact that Next was returning the reference. But it also makes sense, right, because of the fact that Rust doesn't actually differentiate between different things. It lets the borrow checker work out references and pointers and everything else. Whereas in something like C++, you have to be very explicit about whether you are a pointer or a reference or a value or some sort of double dereferenced address of operator to get around some weird case. Okay, so what do we do? We want to take ownership of a work item. We actually want to add... That's way too big, honestly. It does have a U8, right? What's the smallest integer type it goes down to? Yeah, U8 will do. Hang on. I mean, that's very true, Seth, yeah. But at this point, I also kind of don't really care so much. It's more the question of, at this level, how many priorities am I conceptually saying I want you to have? Oh, I absolutely get it. Frankly, I'm not sure I even want a U8, but... you know, U8's just about as small as I can go. Oh, neat. Oops. It would help if I wrote that correctly. There's another thing, actually, I wanted to have a look at that I know they do in here. And I kind of want to steal a little bit how they do this. And now I don't remember where they do it. I thought it was... Yeah, it's in here, right? Because they do a build user... I can see that being useful if you want to, particularly for those people who are doing the work of converting legacy C and C++ code to Rust. So that they've got like a wider interop surface between the two. But starting something new in Rust, I don't want to be doing that. Do they do that? They don't do it as an impl. Although, there is a part of me that thinks that would be quite neat. So this explicitly doesn't have self. That's not the right word. Wait, was that? Oh no, it is actually a method, not a... That makes sense. Do they have like a range thing like in Python? Is what I would really like. Are in control flow? Okay, so break and continue exactly what you'd expect from every language ever, which is always good. Wait, is this not the same one? Oh, okay, there's 3 different books. That's why it looks similar but not quite the same. Yeah. Yeah, but I was looking in book, not in by example. So yes, thank you for that. For and range. Because range is what I want. But all their examples... I might just have to try it and see. Wait, why is Doom Runner open? That's not meant to be open. Because basically what I want is for I in 0 to Qs. And I don't know if it's going to let me do this, but we'll see. d.qs.push vec new d. What did I actually just call that? Build. E.Q's 0. 0. And that should be 6, and that should be 1. And then we watch it explode. Okay. Is that not... Oh, okay, fine. So you're supposed to do it that way. And then I need that other thing to do that. The type back work item cannot be indexed by U8. Okay, so need to look up slicing, I guess, next. But let's see if this at least fixes the other problems. Okay, slice indices are of type U size or ranges of U size. So actually, doesn't matter, that has to be U size. Oh, that's... yeah, okay, let me do a thing about that. I can fix that, probably. I will get smaller. Ding. $33. Oh, because it has to be mute self, right? Yep. Oh, in fact, yes, then it tells you, because it's Rust and the compiler helps you. Wait, that doesn't need to be mutable? Oh, okay. See, this... yeah, this is another place. Actually, I should also probably jump up slightly so I'm not hiding behind my own now playing. Bing. This is another place where C++ was making me do more than I needed to. Because I believe, so I put this as mutable because conceptually we are changing something at least owned by the dispatcher when we add work items to it. But we're kind of not. So the dispatcher actually stays the same and it's internal vectors that are different. So in fact, the dispatcher isn't mutable here. Although it probably would be in C++ terminology. No, except now it says it needs to be mutable again. Okay. Yeah, I don't know. It works, though. Oh, yes, okay. So it had that error because, yeah, fine. That makes sense. See, it's all a learning experience, right? But we have some basic dispatch testing. So it will take work items and put them into the correct buckets. Yeah, well, it depends. In C++, it depends which things you call on it, right? Because you could also have it const as long as you only called const methods on it regardless. I hate const in C++. It's so horrendous. Like, I get why it's there and the value it has, but it really is such a pain. I mean, also at this point, you'd hope Vector had it propagate correctly. Oh, I also need to mark this as a test. Still only need 3 queues. In fact, let's just do this as batches. Because I don't really care about running things at this point. I'll stick another one of these in. Oh, it's one of C++'s design problems. But yeah, again, this is one of the reasons that I've been wanting to try and actually get into Rust, particularly now the Rust docs are a lot better than they were the first time I tried. Because it does have a lot of these things as default, which I think is valuable and powerful. And yeah, I do kind of just want to start playing around with it a bit more. The bit that's going to scare me is when I start adding threads to this, though. What am I trying to do? Assert d dot queues 0 dot len should be 3. And then 1, 2, 3, 4, 5, 6, and 4. In fact, I could probably do something. Let me read up a little bit more on Rust vectors. Because I could probably do something quite interesting here, I think. Okay. What I'm thinking of, so I'm kind of thinking a step ahead. Let me go back to a Scratch thing in here. So You have 3 queues of work, which we are calling 0, 1, and 2. And you have a bunch of items in each queue. The queues can all be different lengths, as we have now proved. This is absolutely fine and correct behavior. And then you have a thread wants to come in and do some work. Now, nobody's doing any work yet. So this thread says, hey, give me the highest priority work you have. So the dispatcher can then say, okay, well, I have this priority 0 work that no one is doing. This thread takes this entire vector. So it ends up with these 4 items in it and replaces this with an empty priority 0 vector. Because I should be able to just get Rust to transfer the ownership out of one object into another, right? And if I just transfer this vector, then this thread can happily go off and do work somewhere, and somebody else can come and give more work. That's the thing I'm thinking. But I need to be a little bit careful about this. And I haven't got to actually doing any of the thread stuff yet, so that's going to be a whole other fun thing to do. I also... That can go away. What was this? Oh, that was live split stuff. Yeah, this is what I'm thinking, Seth. Is the hard part is... No, there's a bunch of things that are tricky here. The other problem you have with it is that you still need to handle some amount of concurrency. Because if you have one person trying to put work in while the thread is trying to take it, they both want mutable references. Or in fact, one of them wants ownership and one wants a mutable reference. And that's going to cause problems as well. So it's the moment a thought experiment, and it's going to take some playing around, and we'll see if we can get that to work. Because there's a whole chapter down here somewhere. There probably is in this as well, right? About unsafe operations. Yes, those. Oh no, I don't like raw pointers. Close that. Close it. Make it go away. Go anywhere else. Okay, so there's just a stud thread that you can spawn. There's a lot of these things I don't want to... Ooh, foreign function interface. Neat. Okay. I need to stop getting distracted by fun things. Oh, absolutely. It's like I said earlier, right, is I am not coming into these streams particularly trying to pretend that, like, I know everything and I'm the greatest engineer ever. Like, I know enough to know what I'm doing and know what I'm trying to achieve, and I'm trying to learn a completely new language. And it's like, yeah, I'm gonna look like an idiot a whole bunch. And I'm gonna get distracted by things that look interesting in the language a whole bunch. But, like you say, this is the point, and it's all a part of the learning process, and it's kind of fun to go through. I'm not out here trying to, gatekeep anything or, say you should only do this if you're already brilliant. If people are interested, just have a look and start poking stuff. Like, honestly, these books now have some really great stuff in them. Is one of the things I've been noticing in here, like in these summary chapters, it says, hey, we've given you some examples, try just writing code to do this. Like, these are, especially if you're completely new, I think these are great starting points. The only reason I'm not is I already had an idea of a thing I wanted to build that I at least know some ways to build and some ways not to from past experience. But yeah, there's some great stuff in here. And it's a lot easier to get into Rust nowadays, certainly, than some other languages that we might have been discussing already today. Studmisk. Oh yeah, that was Threads. So you just spawn. Also, you can... Oh, okay. So it's moving in what in C++ or Python, I guess, would be a lambda. Also, here's the example where they use a variable. Yeah, I've deliberately put off closures for the moment because there's a lot of stuff in there, and I know I will completely overload myself and forget everything if I do too much at once. But this is why I've been building this thing up fairly slowly, so... Also because it's good practice for actually making sure that things are tested properly. And yes, I should actually write the tests first, but... I've completely forgotten already what I was just going to do. Oh, that's right. I was looking into how do I want to take work. I should actually... Okay, cool. Everything ran. Just occurred to me, I've not actually run the complete test suite at any point. I should make sure I haven't broken it. So, I wanted to look at vectors. So yeah, pointer length and size. So yeah, it works very similarly to the C++ ones. It will do vector reallocation. More vec methods can be found under std_vec. Index and index mute. So you're not going to... No, yeah, it should move, shouldn't it? Tell you what, let's do this experimentally. Oop. Add 0. This doesn't really matter. So we want to make sure that it has actually added. Then we want to equal d.q plus 0. Explicitly not a reference. So what we actually want to happen is that. I mean, you're also doing a lot of fun stuff with that reverse engineering, though, Seth, so I completely get that. Cannot move out of index. So it does try to move, but vector very sensibly doesn't let you. Yeah, you'd have to explicitly swap. Because I'm thinking you probably have to do this anyway with Rust because of the strictness it puts on the various safety things. Yeah, exactly. Also, I think it makes sense for a vector because you'd have a vector with dead elements in the middle. So it absolutely makes sense that vector doesn't allow you to do it. And I didn't expect it to. But it does try and do the thing I expected, which is nice. But you can't just take a reference, even a mutable reference, and work on it, because somebody else who wants to add work is going to try and take a reference to the same queue. And they need a mutable reference. So regardless of what you have, there's going to be a problem. So I think the only way is to swap. Is there a neat swap function is the question. It swaps two elements in the slice. It would still need to be guarded, but the surface that needs to be guarded is a lot smaller though, right, Seth? Because you only have to guard the point where you're doing the swap or the add. Otherwise, if you just took the direct reference, you'd have to guard out anybody adding work until you had finished processing the entire queue. Does pop do what I expect it to do? Yes. Okay, nice. Yeah, I was just curious if there is like a swap or swap instant. Swaps the values at two mutable locations. See, don't just swap with a past value. Take your mute V. Okay. So should be able to do that, right? So what I actually want is... So it's in stud mem, and then you do mem take. Was that the right? Oh, use, not using. Again, C++ brain. No, wait, that's dest. Oh, right, yes, okay. No, wait, hang on, wait, what? So they take all of... Oh, right, yeah, okay. And I probably then also need to do that, right? To make sure it knows. Oh, okay. Warning, but passed. Is that, yeah, because this doesn't need to be mutable, because I'm not actually mutating it anymore. Okay. Yeah, no, thank you for that, Seth. That's... Because now as well, I should be able to do... queues 0, 0 dot run with 4. Let's do these checks the right way round, shall we? And V should now still be the same. And we should be able to assert eq v0.run for, also I know this number is wrong, this is now 5 because I changed it deliberately. There we go. We know how to do it. So, yes, there is, as you said earlier, Seth, quite correctly, we still need to do some guarding when we get threads involved. But now we only have to guard this call and this call. There's a whole bunch of error checking I'm not doing yet, which I'm aware I need to do. Oh, yes, right, because... You're with me, while my eyes to sleep. Because now we should just be able to do this, right? There we go. We now at least know... Okay, so we can make work items. We can add them into prioritized buckets. We can take queues of work items. We've only got the really scary bits left to do, really. Hey, Sylvie. Yeah, we're getting somewhere. I'm kind of happy with this. Yeah, how are you doing? What's the Rust comment syntax? This is a thing I should have looked up a long time ago. Okay, it's just slashes. Fine. Oh, I'm not too bad, thank you. Yeah. I've never used Rust before, so I'm trying to learn, and also realizing I should be commenting my code, because otherwise I'm not going to remember what the hell I've done. Yeah, this test we don't particularly need, because all item queue is a type def around a vector, so... Everybody needs somebody. Although, like I was saying earlier, like, looking through the Rust book with some of the stuff they've got in here, like the descriptions and the suggestions for practice, if you ever wanted to try it, there's way worse places you could be starting. Also realizing that I need to tighten up some testing slightly. Whoa, that's not a key I meant to press. So what I'm currently trying to do is I'm building what's called a work scheduler. So the idea is you put a bunch of small tasks in, and it works out how to distribute those tasks, and then you can have individual threads, so like little localized worker units, that will take a priority of work and start working on it. We haven't got to the threads part. At the moment, I'm just working out some of the basic stuff, so... Yeah, this afternoon probably, Seth, I'm going to start setting up this in my Gitty instance here to set up CX. But yeah, so... to kind of work through this from the start, Sylvie, or for anyone else who's interested and afraid to ask. So a work item here is our most basic unit. We take what we call a bin op. So a bin op is anything that takes two integers and gives us an integer back. It has some priority. Lower is more important than higher. And it takes the two parameters that you will put into your bin op. So you can make a work item that adds 2 and 2, that's a work item. You can make a work item that adds 3 and 7, that's a work item. You can do multiply 1 and 4, that's a work item. This is, like I say, just a really small unit that says, hey, here's some work I want done. You can obviously write much more complex methods than these, but for learning, these are fine. Work items get put in item queues. So for each priority, we will have one of these queues. So a priority 0, priority 1, priority 2. You can load up the queues as much as you like. The dispatcher, somebody has to work out priorities. So you have a dispatcher that holds all of this. This is not going to always be called dispatcher, probably. So you say, okay, hey, make me one of these with 3 queues, with 7 queues, with 115 queues, however many priorities you want. For testing, we're using 3 because it's fairly small and easy to deal with. And it sets up its internals so that you have the right number of queues. You can then add work. When you add work, you take a work item and you say, hey, how important are you with your internal priority value? I will put you on that queue. Great. So from the outside, you don't need to work out which queue to put it in yourself. You go to the dispatcher and say, hey, I have all this work. Please put it in the right places. On the other side, we've just been working out how to claim work. So if you want to do some work, you come along and say, I'd like to do priority 0, priority 1, whatever. And the dispatcher says, great, here is your big bucket of work to do. Go away and enjoy your work. And then all the rest of this is testing. So we are testing that you can make a work item that does add or that does mul. We've also internally, so this sub method is not part of the main module, but we want to make this extensible. You can add whatever you like to it. You can make any method. I'm trying to run through this relatively quickly. If you have any specific questions, like, feel free to ask and I will try and explain it. Basically, like, think of it a little bit like if you wanted to do your homework, right? And okay, we're doing very basic homework here. Somebody gives you a sheet of like basic math problems, but you don't want to do them all yourself. And you've got 2 friends who are going to help you. And maybe you're the best, so you do the harder ones, and you divide it up that way. That's your priorities. So hardest, middle, easiest. And you want to make it go faster, you all want to do some stuff, so you divide it up that way. You work on your hard ones, your friends work on the medium and the lesser ones, the easier ones. But maybe your friend who did all the easy problems runs out really fast, and they're sat twiddling their thumbs for a bit. So they go and go, okay, well, I'm going to go up one difficulty, and I'm going to do the last problem you were working on. So they'll take something off the back of that list, and they'll work on it. So now they're both working from opposite ends down that same list of work. Have you just had the same thought I did, Seth, about how we're going to deal with work stealing when we get there? Oh, okay. I say, does it not have to be mutable so it can add work, though? Yes, so at least once you've built the dispatcher, yes. This is true, yes. At least for now. Because there is going to be something like this as well. And I'm not sure how this is going to affect mutability. Although I guess it should be the same, right? Because the threads will change, but the dispatcher won't. Do I need to start having a look through the docs at the Rust Mutex? Concurrency. Yep, I found it. So I knew I'd seen it in the chapter titles there somewhere, but... yeah, okay, shared state's just the top. Oh, okay. Stood sync mutex, okay. So, you're saying it's... we make this a mutex vec work item. So then I guess this has to be... something more like that, right? Will it actually work it out if I just do mutex new? Or do I have to also do that? Okay. I don't need that to be a mutex, though. This is what happens if you just start blindly changing code. So, how do these mutexes work, then? Okay, so you... So... m.lock gives you a sum, which you can unwrap. Which gives you a pointer? Oh, actually, yeah, that's a good point, because we're not using the, yeah. No, because item queue itself is a mutex. So if we're testing item queue, it has to be. Yeah. I mean, honestly, this test doesn't test anything. I'm more inclined to just remove that test. Okay, so wrapped in a lock result. Lock returns a mutex guard wrapped in a lock result. Okay, so unwrap gives you the mutex guard, which implements deref to point at inner. Okay. Yeah. But doesn't it have to... Don't you have to now, though, do lock dot unwrap? You have to do that, right? Oops. Oh, it needs a mutable reference to this? Does it have to be mutable? Yeah, okay, fine. In fact, it doesn't even need to be a breath, does it? So it's... Can you not do... And then... It's that, right? Yeah, Claimwork is the one I was just looking at, because at the moment this is going to try and take the mutex and replace it with a new mutex, which is not what we want. So you do that. But then we take star Q. And this is now not mute. Thank you. I was trying to work out why the squiggle had appeared. But of course, yeah, because we want the mem take to return it. Yeah. Where? In here? Oh, you're right. We want that. Yes. My next question, though, is this working the way I think it is? Because this is testing the length of a mutex, which I'm not sure makes any sense, right? I didn't have to, but like I already noted in that test, Seth, is if you think out what the test was doing, it was only testing the implementation of vector. Because all we were doing was using our type pun vector Yeah, but we already test work item.run in here because we test it at the work item level. So what that other test was doing was testing that if you put things into a vector, you can then use them from the vector. Oh, okay. Yeah. Basically, yes. It was for me figuring out Rust iterators. That was it. Also, can I do that? I assume I can. Just because it looks slightly more consistent this way, because I'm not using return anywhere else. But yeah, like you say, Seth, this makes it a lot easier because you don't need a mutable dispatcher, and it basically has the thread safety built in, right? Because you can't now have a true race between these two. If somebody tries to add work while somebody is claiming work, they have to wait for claim to finish and the mutex to be released, so... And vice versa. Which is always very neat when some... Like... Well, yes. But the more important thing, I think, for me, is that Rust is... Rust gives you some strictness to enforce just good behaviors and habits. And I'm going to say something that might come across as controversial, but I think is true, which is it's a much more modern and usable language in the spirit of something like Ada. Because this is what Ada tried to do. Ada tried to make it so that you couldn't write bad code. And I don't think you'll ever get away from it being possible, but Rust is the newer version of that approach. Like, make it as hard as possible to be wrong. Which is good. I like that. Even when I was writing C++ stuff or getting other people to. And I mean, if Mike's around at any point, I'm sure Mike got fed up of me saying it, is that we should always make the way people wanted to try and write it be correct. Just make it easier for them to do it right, essentially. I need to run these tests, though, and see where it's currently broken, because it is, definitely. Oh, could not compile. On 133, I've missed an unwrap. Oh, I did. Yep. Yeah, okay. So as I thought, I do still have to do that because you can't take the length of a mutex. Because what the hell does that even mean? This is scoped super weirdly as well. Oh yeah, because it now doesn't need to be mutable, right? 42, what's the problem? It was soaked up. That was just me being dumb. Okay. Fine. I do still have to explicitly do that. Right. And now get rid of all of these extraneous mutes. 103. 125. There we go. No, that was a good spot though, Seth. Thank you. And we'll probably... I'm going to tentatively do that, because we probably need to do the same thing when we do threads. I was curious if we'd managed to add any dependencies. Oh, RC is reference counted. The hell is this? Okay, so what does their code say? You have a reference counted mutex. You clone the counter a bunch of times, so 10. You're moving in counter.lock.unwrap. So you're going to try and unwrap the mutex around an integer. This is, I think, I64 by default. Within this closure, yeah, okay, because the reference counted thing can't be sent between threads safely. But it would work, presumably, if you did the mutex around the reference counted. Oh, atomic reference counted, okay. Neat. And that gives you what you expect, which is good. Okay. Async is going to be another big thing to start getting into. Need to have a think about expected behaviors here as well now. Because the thread pool is probably the next major thing to start looking at before I start going back through and adding actual error handling and writing the code properly. Working out the functionality is interesting still. Also trying to think if there's actually like some particularly fun function we could write that takes these two. Okay, we can add work, we can claim work, work's prioritized. We know it behaves so far as we have. So the question that I have about expected behavior is you have, because the thread pool doesn't have to be the same size as your priority pool. But then what do you expect to happen if it's larger? If it's smaller, you always start with the most important work and work down. That's easy enough. Potentially some priority inversion questions. So what happens if new high priority work comes in just as you finish a queue when you're about to pick up the next lowest queue? Like, do you then ignore outstanding work? This is questions that we might steal the Linux nice approach from at some point. But now... Yeah, for now. I'm assuming Rust has the obvious sort of bit operators. Oh look, there's the comments that I was looking for earlier. Okay, so it does have what I expect, which is nice. I might just do something really, really simple first. Let's send and sync. Okay, I don't think I want send and sync here. Maybe I do. I don't actually want message passing, really. Maybe channels is the way to do this. So, the thing I'm thinking here, I actually probably don't want just a vector of threads. I want a thread pool somewhere to wrap up all of this. So you add some work. If you have now added work to a previously empty queue, you go to the thread pool and go, hey, thread pool, I've put work on this priority, get someone to do it. If you can. But you don't want the threads to be constantly there. Oh, you kind of do if you want to do work stealing, though. You want them to be able to sleep and then wake up and see if there's work to do. So we do have thread sleep, which is good. Okay, maybe a worker thread is the place to start here. Also, I was gonna start working one way, and then I started working a different way, and it's got very confusing. So let's... Okay. I'm not sure this is going to necessarily work neatly the way I want it to. I might actually need to do this after all. Then we do a self.dispatcher.claim work prio. What's the unit on this sleep? Also, what do I need to include to get this? Stud thread. That makes sense. Oh, and it's got a stud time duration. Okay. Oops. Oh. Yeah. Because you don't get to do default values, I don't think, do you? I kind of jumped the gun a little bit on what I was actually doing. Also not sure it necessarily matters, because the first thing you do is you do self.running is true. Also, this definitely is mute self. This I need to wrap up, I think, is part of the issue here. No, let's do this correctly. Ah, this is where I need to start looking at return values properly, isn't it? That's, there is... syntax, associated function... Associated... Oh, yeah, okay. Multiple impl blocks, summary... I think it's in error handling? No, it's not in error handling. There is a thing I'm sure I saw. Option and unwrap. Here we go. So we need it to return option. Oh. Should have been that for a start. Right. So we lock the queue, we unwrap it to get the actual queue. If it has work in it, we take it. Let's actually write the test properly first. So I know what I expect to happen. So, what I expect, if I add a work item, whoops, that does op add priority 0, and then some params, it doesn't really matter. Right, if I do d.claim highest work, then we assert v.len 1, because it should be the highest priority work. v.unwrap.len, because option now. And then it should be 2, and then it should be 3, and then it shouldn't actually be anything. Yeah, so unwrap will panic on none. The adult has seen it all and can handle any drink well. All drinks are handled explicitly using match. Okay. Oh, okay. No, I've done the wrong thing then, haven't I? So actually, in claim highest, what I need to do is sum. To Q. What's V? V is a mutex. So we lock it to get a mutex guard, we unwrap it. Yeah, here, it's the same as here. That should work. Oh yeah, I was looking for testing for none. Actually, what I was doing. No possible absence is what I want. So, is it then I just assert eq v none? Is that what we say here? Let's go to the top. Dispatcher. Expected named. Lifetime prominent. Okay, but this is. Stuff that we don't necessarily care about right now. No. What I wanted was the comment it out button. See if I can remember how to do this the other way. Oh, can it only go so far? Okay. Fine, we're now not using those right now. Mismatch types. So they return option string with some string. So we return option item queue with some item queue. Why are you expecting empty? Oh, actually, I don't need to do that, I don't think, do I? So, I mean, we're still in a scope where we have it locked. Okay, that doesn't change. I didn't expect it to. Why? Self-took use. Do the thing. If you run out the end of the 4, you return none. That's fine. I mean, unless it, like, implicitly does that. But that... seems unlikely. Yeah. So I mute. Expected mutable reference mute blank. Found mute vec work item. Why are you expecting that? I mean, we are going to option item queue. I don't see... What am I missing about how option works? So you can make a sum to fill an option. You can make a none to fill an option. This is using result. I don't really want to use result. I want to use option. Hmm. I kind of wanted examples where you use functions that return option, because that's the bit I'm struggling with. Okay, map to option. Spec to option. Oh! Do I need to do that? No, okay. I'm really not understanding what I've done wrong here, clearly. Panic! Don't panic. Don't panic, Mr. Mannering. Refutability? Oh, okay. Yeah, that's not what I wanted. Macros, source files, additional action, items. Function return type. This is, yeah, a little bit deeper than maybe I need right now. Maybe this is just Google time. Oh, wait, hang on. Did I do the obvious thing? No, I didn't. I didn't have the... Oh. Did I do something? I'm not. Yeah, this should be. It's because I was trying to steal self.qs, right? Is probably what it was complaining about. No? Yeah, okay. Although, did that not go away if you do return? Is this just some strange case where you actually have to use return? Because that seems odd. Yeah, that got rid of the error. Huh, interesting. We're not using thread, we're not using duration. So, such a partial eq might be missing. Derive debug. That's not what I want. How to process an option T. No, I'm not dealing with result. I just want to know why option wasn't working. And how to compare against none would also be useful. Yeah, so you can't unwrap a none, which makes sense. Just have an okay. Okay. Oh, V dot is none. That would do it. I don't care about those warnings right now. For now, this will be fine, and I can work it out in a little bit. Ah. That's because... where am I doing this? That does in fact need to both be mutable. Okay. This is fine. Those are the warnings we expect. I am going to take the opportunity to disappear for a few minutes to have a quick break. And then we will come back and do some more on this because we're making a hell of a lot of progress. So yeah, stay tuned. I'll see you all in a little bit. Alrighty, let's get back to it. Now, yeah, okay. I know what this thing is doing. It's all fine. I've managed to refresh my drink, so I can hopefully keep talking for a little bit. We will see. So as long as we're taking a short break, we should probably check on our... Everything is still going here. This is all fine. It's the, obligatory idle checks. Don't need to imbue things at the moment. Auto purging is going to be a big thing to get. Don't really know what our next step is offhand. I think it's just work through rituals for a little bit. And should be fine. Oh. Goodbye, all of the people. That's fine. This is fine. Just increase candy production. Made some progress on this since yesterday as well. Anyway, right. Back to the important things. Where were we? So, let me go back to the section further up on ownership, references, and borrowing in here. Yeah, that's not mutable. So you've borrowed it, but not as a mutable borrow. So I think, in theory... Again, let's start writing tests first. We need our dispatcher. How do I create a thread? Just thread spawn. Does that need to be mute? I'm curious now. I'd assume. No, okay. Cool. What's it called? Main loop? Yes. And then we also you did expect some function arguments. Well done. I need to stop forgetting to put the parens in. That's what I needed to do. Yeah, that is what I was supposed to have done there. But I don't want you to take ownership. That's the thing. This might be a place where we then have to use reference counting explicitly. Because you're not allowed to do this, right? That gives... Oh, yeah, it's where I create it, because you can't give default values. That's why you have build methods. Oh, okay, that's what it means by raw identifiers. That's not helpful to us right now, though. Definitely don't want enos. Maybe this is just because I'm thinking in the wrong language. Because... I could do this, right? And then we just don't want self.dispatcher. And what do we even use self for? And we don't even need this, right? We can... That goes away. But then how do we stop this from outside? That's why we did it the other way. At least for now. But we're not really allowed to do that, in fairness. So, I think about a different way of achieving what I'm trying to do. This is probably where a channel comes in, right? Maybe... running equal... no, let nuke running equal false. Running equals... threads running dot lock dot unwrap. Is that not? No. Where's the... Bum, bum, bum. I want super and self.
Another appointment in half an hour now. Where to start? Oh, how about this one here? Everything's moving.
I saw the thing I want earlier. I don't remember which section it's in. So I saw them using const somewhere. It's not that I actually want to use const. But what I want is... Oh, globals. That's the word, isn't it? Global would be the right word to look for. Static. Okay. There we go. That should do it. I dislike that intensely, but sure. And then down here, we need to threads running dot lock dot unwrap equals true. Let's just be clear on the scoping. We now don't need to do this. But we do this. Fine. It still keeps the scoping I want. I probably have to do the same up here, right? Oh, is it happy as long as you don't write it? No, it says reading from is also unsafe. Although actually, that doesn't have to be mute, does it? Because it's a mutex. I think. You know what? Let's let it stay that way for now. And if it says we don't need to do this, then we don't need to do it. Oop. Because it's not even called that. Should be taking an argument now, though, right? Yeah. Oh, yes, because it complained about the casing and I changed it and forgot to finish changing it. That would help. Unexpected argument, but it... shouldn't be. We're down to only 2 errors. Okay, so it has to be specifically a fun once closure. All closures implement at least this trait, because all closures can be called. Closure moves captured values out of its body will only implement fun once and none of the other. Okay. T, option T. Hub fun unwrap or else to T, where... Okay, so that has to have a trait. Okay. Oh, the double pipes the capture list? Or the argument list? Okay, it's the argument list. Okay, and that's a very simple closure. Let's just capture... Okay. So it will automatically borrow. Fine. So do I not just do... Wait, check the syntax again. also need to unwrap the join. Hey, only one previous error. Why? Um,
1, 2, 3, 4.
Wait, what? Oh. I shadowed the function I was trying to test. No wonder I got confused. Then do I need the closure is the next question. Oh, right, yeah, okay, because... I don't want it to take ownership. I was trying to do this without having to use smart pointers. I don't really want to go down the smart pointer route unless I absolutely have to. Why does this look like a Robotnik face? Ah, because it's Copilot. Get it away. Okay. Alternatively, can I don't want that. I don't think. Hmm. So you want to move everything because the closure you have might live longer than an object it uses. Yeah, I think... We know it actually can't in this case. I mean, okay. For the sake of the test, we can fix this, right? Because we can just do this. But that's not going to work in the long run. value assigned to running should be red. It's red here. I mean, I'm assuming because it does save things by default, you're not allowed to just do that and say, look, I'll assign it later, honest gov. So much of this is, like I was saying this morning, it's just changing how I think about things. Okay. So we RC new, and we have to use stud RC. That was the bit I needed to find. And this takes in one of those. And in the test down here, we RC new. Oh, except, yeah, now we actually don't want it to move anymore. Thank you, compiler, for telling me I missed a semicolon. I will say the error messages the Rust compiler gives you are so much better than many others. It did. Controlling access on mutexes. Yeah, this is kind of where we are, right? Oh, yeah, of course, because you can't just use RC, you have to use ARC. That does make a degree of sense if you think about it for even a second. This is const anyway, so that shouldn't need to be mutexed. But then we do move here, apparently. Which seems counterintuitive, but that's what the doc says. Oh. They shadow it out. That's what I missed in the docs. Fine, okay, you actually do have to. Oh, yeah, and I now get rid of this bit. Now we're just back to reference to mutable static. But this is really, I think... okay, so... and then what we're doing? We're doing... Yes, just lock, unwrap, right? Oh, yeah, what the... I did something very weird for a second there. Oh, because I forgot to clone it before passing it into the thread. So I need to find a better way to write this test. But the thing works. What are our warnings now? As I thought, yeah, because it's wrapped in the mutex, it doesn't have to be mutable. Because we're not changing the mutex, we're changing the value protected by the mutex. And the same on 67 with... Oh, actually... Oh, yeah. This is the other one that I just don't necessarily have... Actually... Return. No... It's not in special, is it? No. The Rustonomicon. Okay. This is a lot easier if you can scope things the way you want. Wait. Maybe I'm just trying to be far too clever with this. Welcome back, Seth. You just missed me having lots of fun starting to work out how to use atomic reference counts. So, the reason is, once I build a thread pool, the thread pool is going to have to dispatch threads to go and take work. So, the worker thread method needs to know which dispatcher you're taking work from. The problem is, you then can't get into any of the interesting bits in the dispatcher to take the work because you're now in a multi-threaded context. You can't just borrow it because you're not allowed to borrow across threads because that would be unsafe. So it all ended up at the point where I arced it for the sake of being able to say, okay, look, yes, I know technically you believe there is a case where the closure might run longer than the dispatcher is alive. That actually can't happen in this code, but never mind. It's an error to do anything else. And in general, it's a fair complaint. I'm not saying they shouldn't have that error. So yeah, I've allowed it to be arced so that the worker thread, while it's running, knows it has a dispatcher. Yeah, there's all sorts of stuff. For right now, it was a lot easier for me learning to just basically use a shared putter, right? I ended up doing the same with this because I was trying to use a static mutext Boolean, but even wrapping that in an unsafe block, it doesn't like it for Rust 24 compatibility. I will have one slight issue with that statement, though, Seth. It's not shared putter all the things. It's shared putter the minimal number of things. Because I am far too aware of the problems of having reference counted things that could all look at each other. in this case, it is specifically so that both the test and the child threads of the test can reference the same object. And at that, I spent some time fighting to not do this. So yeah, I think the next step is probably, now the tests are working again, like, I should actually run everything. Run all of the things. It is going to take a second, because I now have a horrible test that I don't like. But we're good. Yeah, everything builds and runs and passes. There are no warnings. We're happy. Right, let's learn about explicit lifetimes, shall we? Well, hopefully that also helps make it easier to read, right? Oh no, it's shared behavior, not shared access. Validating references to lifetimes. Yes, we don't like dangling references. There's a borrow checker that compares scopes to determine whether all borrows are valid. Fair. Yeah, actually, I think these are 27. You come over here. I'm just curious now. So if I could remember the model number, I would do that. I'm trying to find the bit in this where it tells me the model number. Mine's got the brand, but not the model number. Oh, actually, I can find it weirdly easily thinking about it, I think. EL2870U. .28-inch. Okay. That would make sense from the name, really, wouldn't it? Lifetime annotation syntax. Okay, lifetime annotations don't change how long they live. Rather, they describe the relationships of the lifetimes. With multiple references to each other. Start with an apostrophe and are usually all lowercase and very short. Reference to I32, so I32 has a parameter, and then a mutable reference to I32 that has the same lifetime parameter. Returned reference will be valid as long as both of the parameters. Okay, so you return it with lifetime A, and you take parameters of lifetime A. . So this returns a string that is valid as long as the first parameter is valid. Let's return the first one rather than the longest. Yeah. Right, this is how we do the other thing that I tried to do at first before I realized I only needed a function and not a struct. So yeah, when I was trying to have a worker thread struct that just had a reference to the dispatcher, I could have done it this way. So this has a field part that holds a string slice, which is a reference. This annotation means an instance can't outlive the reference it holds in its part field. This one is starting to hurt my head a little bit. I might need to come back to this tomorrow and refresh myself on some of this. Yeah, I'm not going to take in any of this bit, I don't think. Oh, the static lifetime. Interesting. I'm ignoring whatever that at the top was. Because I'm curious about if you can have like a fun once closure. Yeah, I used to have that in, and then I lost it during an update at some point. Well, okay. I didn't have it as an extra parameter. I did set the as you can do one thing with a user mode flag to turn it off. Do you happen to know what the extra parameter is, Seth? Because I don't remember. And since I no longer work with Fabs, I can't easily poke him and say, hey, Fabs, can you tell me what that thing was again? That's UDM, thank you. As I thought it was UM, not UDM. Settings. Search. Edit. Do you actually have to add a new one? Googler. But yes, the fact that I forgot it was UDM. Yeah, I'll do that later, Seth, when I'm not streaming. Because I was convinced it was UM, not UDM. Yeah, no, I greatly appreciate that. There's another one as well that Fabs told me about that wasn't 14. There's another number, but it says something that Google force it on everyone and don't use it themselves to the point they can turn it off easily. This code needs so much tidying up. That might be a job for tomorrow, is to start coming through and understanding the proper, like, error and result handling systems. Also, here's a question, Seth, that you might have an answer to, since you do know this better than I do. Where am I looking? In here. Can you not... Do you actually have to explicitly return a sum? Because I was trying to find it in the docs and it doesn't seem to say. But if I take out the return and the semicolon, it errors. And it works fine if I put it back in. But I can return none on its own. Because it just seems very odd to me. Fair enough. I thought I'd ask. I was poking a bunch earlier to try and find out. In the end, I worked it out based on compiler errors. Because, yeah, if I didn't do this, then it found there was no type at all. So I'm wondering if it's just there's something slightly odd about the way sum is defined that means it doesn't work quite the same way. Anyway, it's not that important, just curiosity. No. Before I do this, I do want to see if I can do the explicit lifetime thing. Because if I can get rid of all of the arcs, that's going to make this code so much nicer. That actually might have to be arced anyway because it's a mutex, but yeah, let's leave that one as it is for now. Actually, what am I doing? Everything I was just saying, completely irrelevant. Never mind. Because of the way this is going to get wrapped up, that's still going to be the case. Python has some absurd meta magic. But I think Python's almost starting to go the way of C++ in a lot of ways of adding so many things it becomes very hard to keep track of. I wasn't saying anything huge, Seth. I'm just saying Python's got a lot of bizarre and absurd meta magic that it can do these days. There. Use the right syntax. I was looking at this thinking, this looks wrong. Now I know why it looks wrong, because it's wrong. There we go. Oh, that is certainly a question, Seth. No, I don't need the mutex on that. I just need the arc on that. There's always more to learn. It's one of the... I'd say it's one of the great things about life. It's also one of the terrifying things about life. That doesn't actually need to be mute. Yeah, like I said, there's always plenty to learn. The hard part is trying to not do it too much too fast, right? I still hate it, even while I copy it. I wrote that as Python for a second. Oh, because it's not that, is it? It's thread handle, I think. Join handle. A join handle of what? Do we know? Can we know? I don't think we can. A join handle empty. Fine. Still 2 previous errors. Yes, because I forgot parentheses again. You can tell my brain is shutting down. Yeah, that was the one that was supposed to have been mute. I'm actually not entirely convinced. Yeah, the other one didn't need to be. That was me doing the wrong thing. Ah, 1 previous error. I can't even find the damn code. Here. Huh. And it makes sense that when you join a thread, it takes ownership of it. So why did this work? Join handle T. T is empty. So yeah, okay. Oh. No, I know why it's not right. That's not a 0. Yeah, cannot move out of index. Right, that's what I thought, because it was turning into an iterator and I was trying to move out the iterator and it was all going wrong. This is much more clear that it's because of the fact it's in the vector. Which means we're going to have to do something odd, aren't we? We should be able to do this, right? It needs to be unmute, though. Could probably do that actually with the iterator and just take through the iterator, but that scares me. Because now we are changing... Oh, the trait default is not implemented. Okay. What if you have a whole bunch of handles is the question. owned value when we call join on it. Yeah, that's not waiting for all threads, that's waiting for one thread. Yes, I know to save the join handle. The problem is I want to save more than one join handle. And I can't do it in a vector. Hey, reference cycles can leak memory. That's what we were saying earlier. Okay. There's no default value. And there's no copy, because copying it doesn't make any sense anyway, because what would it mean to have two handles to the same thread? Can't move it out of the vector. Wait. Stop writing Python. And pop actually removes it, right? Oh. Oh, because it's an option. Oh. So we've already guaranteed it's non-empty before calling pop. So we want to th.unwrap? .join.unwrap. I thought I already made it self-mutable. Did I apparently not? Oh, I didn't. Oops. Oh, of course, now it would have to be, because it's directly changing its own vector. Now this has to be mutable. Yeah, and to be fair, I didn't take that long for lunch. Honestly, it's nice to know I still can. So actually, that isn't needed now. That is always the question, isn't it, Seth? And it's a good question to stop and ask, absolutely. But, yeah, it's not always a comfortable question to ask. I think it's time for a quick idle game check while I let my brain recover. I don't really care about glyphs, because I never use them apart from heavy. Yeah, we'll take a superior option. Rarer discoveries. No, it's been a lot today getting into this completely from scratch. I think we're getting somewhere reasonable with it. And at some point, I'm probably going to start, hopefully this week at least, I'm going to look to be starting to try and play with Rust and graphics a little bit, which will be fun. We'll see how that goes. I don't remember what I was even trying to do in here anymore. I need more chocolate. Right, your hat. Why are you yelling event? No, everything's fine. Okay. Let's try and read this again. Instances of this cannot live longer than, or cannot be valid for longer. Yeah, I'm not sure if this would actually have fixed our problem anyway, unless I can work out how to put lifetimes on closures. Because the problem is that the closure could live forever, functionally. You need to specify lifetime parameters for functions or structures that use references. The reason is historical. In early versions, this code wouldn't have compiled because every reference needed an explicit lifetime. At that time, the function signature would have been blah. Okay, so I wouldn't say that's elided so much as it is inferred. Okay. Imply that assigns a lifetime parameter to everything that's a reference. Exactly one input lifetime parameter that's assigned to everything. There are multiple input lifetime parameters, but one of them is self or mute self because it's a method. Lifetime of self is assigned to all outputs. Yeah, that makes sense. Everything gets its own lifetime. Okay, all the parameters do. So we have A and A. There is exactly one input lifetime, so A goes everywhere. You have A and B. So you can't apply parameters itself. I haven't figured out what the return type's lifetime is. Yeah, okay. Special lifetime is static. All string literals have static. Fair enough. Okay, so you take an X and a Y and a thing. I mean, could probably also use generics to make this work scheduler more powerful, right? You'd just have to... Yes, you'd have to do where T is fun wants, basically. Maybe that's a thing to look at as well in my little list of to-dos. That might be too permissive, is the concern I have. Okay, that is just in the track. Use generics. Use generics in the signature. Yeah, okay. largest T takes a list, a reference to a list of T's, and returns a reference to a T. Oh, there's so much in here. Trying to actually get through it. Leave this note for myself. So that's a thought I have there. To avoid having to write the test to sleep and hope that we sleep for long enough, if we know what values we expect and we don't care about the order, we should be able to use a channel to get the test threads to send back to the main test the values that they calculate. Also need to get into packaging. This is definitely one of those cases where the more you learn, the more you find out what you need to learn. Actually, this doesn't matter, because we're going to throw the vector away anyway. I was going to change this to actually pop items out of the list. But given we've already extracted the queue from the dispatcher, it's going to go out of scope down here. And when we throw it away, we'll throw away all the work items regardless, so we don't actually need to do any explicit stuff to tidy that up. I mean, everything passed. Also, these tests aren't actually proving anything. And tests still work, so it's probably a good sign. And in this one as well, I should be able to assert eq tp.threads.len 0, right? Because we just popped everything out, in theory. There we go. And I think at this point, my brain is slightly melty. But much like yesterday, we made a lot of progress in relatively little time. So I'm quite pleased with where things are. They can definitely be better. This is not me saying this is production quality code. Nobody say this was me saying this is production quality yet. But, you know, we've got some tests. We've proven that it's functionally doing the things it should be for the moment. We've got some places to definitely have a look, tidy up, try and write it better. But we do have something. Lies, work item is constructed. So yeah, I am going to wrap this up here. If you are around on Twitch, I think Kin is still going, so we'll pop over and say hi to Kin. If you are on YouTube, then I will say thank you for joining me. Take care of yourselves. I'll see you all tomorrow. Bye for now.